Geometry, Chapter 4, Section 2, Angles of Triangles. Uh, there's a very important theorem. We're going to use it a lot. Um, the name will come up, but the idea is that if you were to have any triangle, if it's in a Euclidean plane, uh, the interior angles of that triangle always add together to be 180. It's just, that's what it does. You can do this as a little test here by cutting out a triangle on a piece of paper, tearing off the corners, and sticking them all together, and you'll see that you actually make a straight line with the pieces. Maybe I'll do that in class, but you can do that yourself. Um, but yeah, some of the interior angles is always adding to 180 on a Euclidean triangle. One thing that we do sometimes, let me draw a triangle here, is we add something called an auxiliary line, which is basically I can take one of the sides and extend it out. So here I've got this triangle. I could also take a ray and extend out one of the sides and make it a little bit longer. I could also maybe make myself a that was weird that it did that. Make myself some sort of parallel line or perpendicular line, whatever happens to be useful. So you can see here the top um, auxiliary line here is parallel to the base. I know that exists when we were in the parallel chapter. I know any line and a point off the line, like the vertex, there'll always be a parallel line going through it. So that can be useful information. But we call these auxiliary lines. All right. So that's just another term that's going to come up a bunch. Uh, Lots of times I'll say extend a side. And what that means is I'm just drawing an auxiliary line on it to get something on the image to help me figure out what's going on. Let's go ahead and use the triangle angle sum theorem. In the diagram, the path of the ball in a passing drill created by four friends. Find the measure of each numbered angle. So when I'm taking a look through the picture here, I can see I've got two triangles. The triangle on the left, A, B, C, and the triangle on the right, C, D, E. And when I'm taking a closer look at it, I can see there's angle 1, angle 2, and angle 3. So one thing I like to do when I start off one of these problems, I just start off, tell me what angle 1 is, tell me what angle 2 is, and tell me what angle 3 is. That's what the question wants. So after I do all my calculations, I already have a place ready to go for all my answers. It's nice and neat up on the top of the section. Now I just need to show my work. Usually it's good to start at angle 1. In this case, it's not. I'm actually going to start at angle 3. Because if you take a look here, I have two of the three angles for triangle ABC. So I know that those three angles, 20 and 78, and the measure of angle 3 need to add up to be 180. 20 plus 78 is 98. Subtract 98 from both sides. And I get myself measure of angle 3 equals 82. So there's my first angle down. Now, there's other kinds of relationships, and we get to keep all of our old relationships. Those don't disappear. So I see a relationship between angle 2 and 78 there. Those are vertical angles. So guess what? Angle 2 is 78 degrees. Now I'm done. The only one left here is angle 1, but you can see, and I'll draw this triangle out separately. I have a triangle here. 61 degrees in the bottom, 78 here at the top, and then angle 1. Well, those three things, 78 plus 61 plus the measure of angle 1, should add up to 180 degrees. 70 plus 60 is 130. 9 plus measure of angle 1 equals 180. And then we subtract 139 from both sides. Need a little bit more space here. And I get the measure of angle 1 equals, 180 minus 140 would be 40. But I didn't take that away. I took away 139, so I get 41. There we go. There are my three angles. So you can see it's nice to kind of set up the three angles that I'm looking for before I start the problem. That way I don't miss anything. I've got a nice neat spot to write them all down. I'm not like looking all around the page for the potential answers. They're all right there. I just show my work below and I'm good to go.